Just a quick update about what the AP exam is going to look like for calculus. So first of all, it's Tuesday, May 12th, which is 5 weeks from yesterday. So we've got plenty of time to keep practicing and preparing. It's going to be at 1 p.m. our time, so like everyone is going to have to be ready to they'll log in before 1 p.m. and then what's going to happen is they'll post a question. The first question will be 25 minutes, so you have 25 minutes, and I think there's a 5-minute to upload your picture, or if you type it, which I don't know why you would, upload your answer, and then there'll be a 15-minute question that again I think they give you an extra 5 minutes to upload the answer. As far as the technical stuff, they'll give more details as we get closer. But that means we need to practice lots and lots of free response questions, which we've already been doing. Your first assignment was practicing differential equation free response, and then we did multiple representation, just derivatives. First assignment this week was graphical analysis, and now we are practicing implicit differentiation. So implicit differentiation is when you're taking the derivative with respect to a variable, and there's multiple variables. So here, see how we have both x and y. When I take the derivative of x, that's going to be 1, but when I take the derivative of y, because I'm taking the derivative with respect to x, the derivative of y will be dy dx. So the first one, it says write the equation of the line tangent to the curve at the point 1, 3. So we know how to write equation of a line. Equation of a line is y minus y1 equals slope x minus x1. And then we have our point right here, right? Let's label it point. So this is my y value 3, and this is my x value 1. And now what I need to do is find the slope. The slope is just going to be the derivative. So I'm going to go up here and I'm going to take the derivative with respect to x. So my first line, derivative of y squared is 2y, but I need taking derivative with respect to x, so I need a dy dx right there. Here, looks like I'm going to do product rule, so off to the side I'm going to say u is negative 2x, v is y, u prime is negative 2, v prime is dy dx. So u prime, negative 2, v, y, plus u, negative 2x, v prime, dy dx. So that's just this term, minus x, derivative would be minus 1, derivative of 2 is just 0. Now we have our first line, and what we need to do is we need to rearrange this to get dy dx by itself. So I'm going to add these two terms over. That gives me 2y dy dx, negative 2x dy dx equals, this got added over, 2y, this got added over, plus 1. Now I'm going to pull the dy dx out. That leaves me with 2y minus 2x. And divide this term over. Now I have my dy dx, and what I want to do is actually get what dy dx is at this point. Remember, this represents your slope. I want the slope particularly at the point 1, 3. So I'm going to plug in dy dx at the point 1, 3 is 2 times 3 plus 1. This is 6 plus 1, which is 7. This is 6 minus 2, which is 4. So this right here is my slope. Oops, you couldn't see my y, or my u and u primes. So then you plug in your slope, and that is the equation of the tangent line. I've got my point, and I got my slope, which I found by finding dy dx and substituting it. B says evaluate the second derivative. Let me scooch this over. The second derivative at the point 1, 3. So I have my first derivative. Let's go ahead and write that. First derivative is 2y plus 1 over 2y minus 2x. And what I want to do is I want to take this derivative of that to get my second derivative. It's super important you guys are being very clear with your notation, right? This is the first derivative. Now I'm finding the second derivative. So that when you upload your free response for the AP exam, they know exactly what you're doing, especially because it's probably going to be on loose leaf paper like this. Okay, so this is quotient rule, which is low d high, derivative of 2y plus 1 would just be derivative of y, which is dy dx, minus high. D low, derivative of this would be 2 dy dx, derivative of that is minus 2. And underneath, the low squared goes. Now we need to substitute in. So I have x equals 1 and y equals 3. So let's go ahead and do that real quick. Now I'm not done yet because I still need to substitute in dy dx. I've plugged in for x and y, but I still need to plug in dy dx right here and right here. Now, two ways you could do this. You could say, hey, this is dy dx right here. Take this, substitute it in for the two dy dx's, which is totally fine, and then plug in your numbers. I prefer to just plug in my numbers here, get what dy dx is, and then substitute it in. So if I were to plug in, this would be 2 times 3 plus 1 over 2 times 3 minus 2 times 1, which is actually what we did earlier, but it's okay. 6 plus 1 is 7. 6 minus 2 is 4. So then dy dx at this point is just 7 over 4. And now we clean up. So this is 6 minus 2, which is, I can do that, 4, times 7 over 4. This is 6 plus 1, which is 7. This is, that would become 14 over 4 minus 2. 2 is just going to be 8 over 4, so this is 6 over 4, which is 3 halves. Times 3 halves. Underneath, this is 6 minus 2, 4. 4 squared is 16. This is 7 minus 21 halves. Ooh, 14 halves minus 21 halves, which is, yay. I think I messed this up. I did mess it up because, oh my gosh, how embarrassing. The derivative of 2y is 2 dy dx. So, shout out if you got that. So this should have a times 2 right here. So this should be 28 over 2, which is 7 over 2. Whee! Now, as I mentioned in the top of the document, because like they can't check and see if you're using a calculator, the test is definitely designed that you may absolutely use a calculator, but you do not need a calculator. So there won't be any questions where you have to do like the derivative in the calculator or integral in the calculator. If you have a calculator, or if you can download one on your phone, you could definitely use this. But if you're like taking the test on your phone, then having the calculator on your phone would be kind of, so maybe if you have 2 devices, you can borrow a sibling's phone to use a calculator on that for that 45 minutes. Okay, I have done all of 1 and 2, right? Or sorry, all of A and B. Now part 2, it says there's a funnel. H is the height, radius is R. And radius is given by this. The funnel contains liquid that is draining from the bottom at the instant when the radius is 1. That's supposed to say when the height of the liquid. So when the height of the liquid is 1, so H equals 1. And the radius is decreasing at a rate of, so that is the derivative of R, or dr dt, and decreasing means a negative rate. What is the rate of change of the height? Okay, so that is derivative of the height, dh dt. Alright, so it looks like we're definitely taking the derivative with respect to time. So let's take the derivative of this equation. Derivative of r would be dr dt. 1/5 is just a coefficient. Derivative of this, you would use chain rule, so bring the 2 down. Leave the inside alone. This is now to the first power, you don't have to write it. And then we have to remember to multiply by derivative the inside. Derivative the inside, 3 is 0, but derivative of minus h would be times negative dh dt. And now we plug in, dr dt is negative 1/2. This is 2/5. 3 minus h is 1 times negative dh dt. And then now we're just keep cleaning it up, trying to find dh dt. This is 3 minus 1 is 2. 2 times 2 is 4. So this is negative 4/5 equals negative 1/2 dh dt. Right, I just moved this negative with the coefficient. Multiply the 5 up, so that's negative 5 over 2 equals negative 4 dh dt. Cross off the negative sign and divide the 4 over. So dh dt, you're dividing by 2 and then you're dividing by 4 again, so that's the same as dividing by 8. Okay, number 3, we've got another equation. Here it says show that dy dx equals. So very similar to what we did in the first one, but now we know what the answer should be, so we really shouldn't mess this up. Let's do our derivative. Derivative of x squared is 2x. Derivative of this, we're going to use u is 6x, v is y, u prime is 6, v prime is dy dx. So this will be plus 6y plus 6x dy dx. Derivative of y squared would be 2y dy dx. And derivative of negative 8 is 0. Trying to get the dy dx's by itself, so let's subtract these two over. Minus 2x minus 6x. Pull the dy dx out front. Divide over. Now, not quite what the answer is supposed to look like, but I do notice that everything is divisible by 2, so let's divide everything by 2. That would be x 3. Oh, that's supposed to be a y. One of those is a y. Oh yeah, that's a y. Minus 3y over divide by 2, 3x plus y. And then I'm almost done. They don't have negative, negative. They have the negative out front, but that is the same as negative x plus 3y over 3x plus y, which does match what I am supposed to do. So check. Now it is asking find all coordinates where the line tangent to the curve is horizontal. So think about a horizontal line. What we know about a horizontal line is that the slope is equal to 0. My slope here is just dy dx. If you want a fraction to equal 0, you need the 0 to be the top. So in this case, the x plus 3y. So I'm going to set x plus 3y equal to 0. If you put the negative sign, that's fine, but I'll divide out because 0 divided by negative is still 0. Now, I want to actually get a coordinate. So I want to know at what x value and at what y value is the slope 0. Right now, I only have one equation, so I can't get both x and y, right? Two variables, one equation, that won't work. But I can rearrange get x by itself. And then I also have the original equation. So see how this is like my second equation that I can substitute into to solve for the x and y values. So I'm going to take this x and I'm going to substitute it in for these x values. So this is going to become negative 3y squared plus 6 times negative 3y, y plus y squared equals negative 8. This will become 9y squared minus 18, y times y is y squared, plus y squared equals negative 8. These are all y squared, so they're all common, is that what it's called? Like terms. 9 minus 18 is negative 9. Negative 9 plus 1 is negative 8. Y squared equals negative 8. Divide by negative 8. Y squared equals negative 1. Nope, positive 1. Which makes sense because I can't take the square root of a negative. Take the square root. Y equals both 1 and negative 1. Remember, when you take the square root, it's both. When you take the cube root, it is only one sign. But for even powers, you get both signs. And I'm almost done, but it did say find the coordinates, not just the y values. So I know that I'm going to have at least two coordinates. One with the y value of 1, one with the y value of 2. Now to find the x value that goes with this, well, we already have this relationship. X equals negative 3y. So if I plug in y equals 1, x would be negative 3.